Well, without further ado, we are at the time to officially start this. And so let's get with the program. And I'm going to turn it over to Dan and let him introduce himself. And because we are in meeting mode and you know, during when he's talking, please mute yourselves and keep yourselves muted. And then, but when it comes time, if you want to ask a question, then certainly feel free, you know, you can put it in the chat or you can unmute yourself. That's the nice thing about doing this in meeting mode is that we can make it more interactive. And it sounded like, Dan, that you were going to do a little bit of interactivity. So.
Oh yeah, I will only be blathering for the first 15 or so minutes while you're setting up your Skynet accounts. And I just want to, I'm not going to monitor the chat. So if there's stuff in the chat, Brian, please interrupt me and let me know. But everyone else, be bold, just interrupt me and shout out and ask your questions. And hopefully there's time at the end. I'm notorious for just rattling on and always running out of time at the end. So get your questions in whenever you have them. So as I was explaining to, you know, I showed up about 5 minutes early and was telling my very sad story. My laptop has decided it's done. I'm still running Windows 7 and I shouldn't be. And this morning I learned that the following keys no longer work on my keyboard. And it may be germane to today's workshop. The keys are 2, W, S, X, Control, and Alt, which made it very hard to press Control, Alt, Delete this morning and get my computer even running. But I managed to get through there. And I think I have everything good enough, but there could be some comical episodes or sad and tragic. We'll see if it's comedy or a tragedy moving forward. It's kind of like a dear old friend who is departing. And this workshop is our last hurrah together. And so you all get to participate in that before I say goodbye and get a new computer. Anyway, let me pull up my PowerPoint here. First of all, let me share my screen. Okay. And see where we are. We'll need this document very soon and I have a PowerPoint on my other screen. In fact, I'm going to move you all to my other screen. Let me take a moment and adjust everyone so I can see as many of you as possible. And fire it up. And switch the monitors, which sort of worked. Okay, so I'm going to be talking about robotic telescope labs at the survey level undergraduate experience. I gave a workshop by the same name last year, but a lot has changed since then. And we have two curricula now. We have Our Place in Space, OPIS, which we began developing in 2008. It's for introductory undergraduate students, first semester introductory undergrad, survey level. Though it can also work for majors. We produce a lot of majors out of this curriculum. And a number of high schools have adopted it as well. These are more your college prep high schools, but it does work at kind of the advanced high school level. And that's been funded recently from the NSF, a $2 million grant, and there are opportunities for instructors, as you'll see. And it's been adopted by 24 schools serving 3,000 students. And last year was only half that, so it's growing very rapidly. The goal, and NSF's goal, is to make this a national curriculum. The second one is the Multi-Wavelength Universe, or MWU, or Astrophotography of the Multi-Wavelength Universe. Astrophotography will be the hook, but it's more than making pretty pictures. And this is a follow-up to OPIS. It's next level activities, and that's in development now. And again, there are opportunities for educators who want to get involved. So this is what we're going to be talking about today. We're going to begin with registration for Skynet. Skynet's my global network of robotic telescopes, optical and radio. And we'll get you all accounts and 10 minutes of observing time. It goes farther on lower quality telescopes and not as far on higher quality telescopes. But for like a 16-inch telescope at Cerro Tololo, our best observatory, I'll get you about 10 minutes of time. And if you're excited and want more, just email me. I can deal with that. I own the printing press. So we'll start with that. And while you're getting your account set up, and I'll show you how to do that in a second, I'll give you a brief preview of the telescopes that are available to our educators and our researchers. Give you a quick rundown of the OPIS and MWU curricula. And then these are the activities, at least as many as we have time for. I'll show you how to submit a basic observation on Skynet. Maybe we'll look at Saturn, but you can also do deep sky objects or whatever you want. And then we'll switch to Afterglow, which is our analysis software suite. And this is all web-based, and students don't have to install anything. It's all web interfaces. And we'll take a look at Moon ID and color combination, which we've been building into it for the MWU curriculum. Then we'll try one of our OPIS activities where we'll look at an R-Lyrae star in a globular cluster if I require the data, since we have a short amount of time here. We've got about 6 days of data, and we will, you'll see how the students analyze that data. You can do it yourself. You follow along and do it yourself, and I'll check and make sure we can use the thumbs up to make sure you're keeping up and measure the distance to this globular cluster. And lastly, if we have time, I'll show you another MWU activity built around pulsars and their polarization. Okay, so that's the plan. Everyone good? Excited? Okay, so first let's take care of registration. You'll want to go to this tiny URL. I have it written over here as well, so I've ended the PowerPoint.
If you could pop that into the chat, that would be wonderful. And that way people can just click on it.
I think I can. Let's see, copy. Remember, I'm keyboard limited. And paste. Yep, so it's in the chat there. And there will be many more links, and I'll copy and paste them as we go. But definitely go here right now. This is registration, and just add your email to this list. We got 4 of you in there already. Let's get all of you in there. Even if you choose not to do anything today, you should be able to follow along and do these activities. But we are pressed for time, and if you get behind, don't worry. This is being recorded, and you have access to come back. My postdoc is watching this. He's one of these anonymous animals up here, and he's grabbing your email addresses, putting them into Skynet, which, if you haven't guessed, is a movie reference. We actually have programs at each telescope called Terminators. So Skynet talks to the Terminator that controls the telescope. And you will receive, it's already been pushed down to the next page, an email that looks like this. And it could end up in your spam folder. So be on the lookout for it. I'm going to give you like a few PowerPoint slides while you're setting this up. There's a registration number here under that black box. It's different for everyone. That's why I have it blacked out. And then you click either of these links and it takes you to a very simple registration page. Choose your username, type your password in twice, enter your first and last name and your email. And you have a Skynet account already set up for you once you get this. And this will connect you to that account. And there'll be 10 minutes of observing time already waiting for you. Again, if you need more, just let me know. So the list is filling out there, and I'll let you do that. And while you do that, my postdoc will monitor and start to create these. Oops, I think this stays over here. I press the go button and I swap the displays. Okay, so while you're doing that, a little bit about Skynet. Skynet has 2 classes of telescopes, prompt and partner. The prompt telescopes are the ones that my team at UNC Chapel Hill has developed themselves. We started out at Cerro Tololo Inter-American Observatory. We're also involved in SOAR, and hence we chose this site. We currently now have 8 telescopes there, ranging from 16 to 40 inches in diameter. And we're developing some advanced instrumentation, polarimeter spectrographs, that may or may not be incorporated into some of these activities in time. In fact, we're rebuilding all of Skynet, front end, web interface, and back end to accommodate this more advanced instrumentation, a global network of radio telescopes, multiple instruments on a single telescope, and all sorts of things that we've learned since we began this back in 2004. And they'll be rolling out next summer. We've expanded to Australia. As we upgrade our telescopes in Chile, we push the smaller ones out to other sites. Our site at Siding Spring was destroyed by an electrical surge, but I've replaced all the equipment and it's there waiting for COVID to abate so I can send my team and rebuild the site. hopefully pretty soon, because we're also involved in the gravitational wave game, follow-up game. And we recently opened 2 sites close together in Western Canada for some Northern Hemisphere coverage. And these are very dark sites with high quality. Now, in addition to the prompt, when you're putting observations in, you may choose to select only prompt telescopes to get the best, most reliable images back. But we also have partner telescopes, people who have fully automated systems. They've come to us and said, can you control our system? And over the years, we've learned how to control every commercial type of scope, mount, camera, filter wheel, dome. In fact, the dome solutions out there commercially for automating them aren't that good. So my lead programmer set up his own company for automating domes. That's proven very useful, and he's very cheap too. So anyway, it's being recorded. I probably shouldn't have said that. I don't know if he'd like being referred to as cheap. We'll see, but his products are inexpensive and high quality. I'll say that. And we are integrating radio telescopes. We integrated our first after the Great Recession. This is the Green Bank 20 meter. I've been a radio astronomy, I'm not a radio astronomer professionally, but I've been a radio astronomy educator for a very long time, very passionate about it. So I was very excited we got about $500,000 Stimulus Act money after the Great Recession. We upgraded this telescope in Green Bank in West Virginia. It's now shoehorned into Skynet. Part of the Skynet rebuild will make it natural. And with our $3 million of DoD funding, we're adding at least 6 more in Australia, Puerto Rico, North Carolina, and possibly more. This would be the first ever fully integrated. Every radio telescope is different. They're a one-off system, different control system. You will be able to put in a generic observation through a common interface, and it will say, oh, we can carry this out with the following 4 telescopes. And you say they're all good or all but that one, and it will carry out with first available, just like our optical side works. It's never been done before except with like VLBI, but this is for education use, and we have secured different percentages on each of these scopes for many, many years to come. So super, super excited about the educational possibilities of the invisible universe. And that's what MWU is largely about.
Dan, we've had just a few people arrive after you gave the initial instructions. And so what we're doing is we're registering people, and I'll put this back in there. And so there's a URL, you need to go there and just add your email address at the end of the list to get registered on this.
Yeah, as you put those email addresses in there, my Skynet is creating a postdoc, my postdoc is creating a Skynet account. You'll receive an email from Skynet, maybe in your spam folder. Follow the instructions, it takes a few minutes. And while you're all doing that, I am just giving you some background information, then we'll have some fun. So what is...
And we keep on having to say this because as you were saying that, somebody new came in too, so.
And just to repeat again, go to that link, add your email, and you have a Skynet account soon. Just check your email. Okay, so Skynet's mission, I've told you about our telescopes. Our mission's split, research and education. This is an education talk, but I want you to know we're very serious about the research. Skynet data is published in peer-reviewed journals every 20 days now. 5 times in Nature Science, and we're the leading trackers of NEOs in the Southern Hemisphere, NASA funding. But we take education, public engagement very seriously. We've had, to my count, 45,000 student users over the years, and a lot of that recently. And there are more that I don't know about. People create accounts, they create groups, and they put their students in their groups, and I'm not even sure what they're doing. But these are the ones I know about. And nowadays, a lot of these are through 4 large programs, NSF and DoD. 2 at the middle school level, which we were chatting about before we got underway. Skynet Junior Scholars that some of you are familiar with, and iData. Both I think are iData for sure, but I think Skynet Junior Scholars is also being managed or overseen, or at least the website, by Tim Spuck at AUI. And these are kind of middle school, sometimes high school level. But today I'm talking about the 2 that I've played a large role in developing at the introductory survey undergraduate level, Our Place in Space, or OPIS, and Astrophotography, the Multi-Wavelength Universe, which we're developing now. A little bit about Our Place in Space. As I said before, $2 million of NSF funding. There's up to $3,500 for participating instructors. We're only 1 year into it, so there's still lots to do and still lots of that money to be had. 24 instructors have already signed up. And this pays for training. We meet once a week every fall to learn the curriculum and once a week every spring for feedback, because we're trying to improve the curriculum as we go and to carry out surveys with your students. We got IRB taken care of. And this will be the largest survey of radio telescopes in education ever done, I think, certainly at the undergrad level. And our education researchers are Michael Fitzgerald, David McKinnon, and their student Rachel Freed, who's playing a leadership role, and she's now my postdoc. And they're also the ones doing the education research on MWU. High quality team if you're familiar with the RTSRE conference. Yeah. This is for survey level undergrads, intro. It's 7 labs, 7 Skynet labs, 2 non-Skynet. We took the approach of what do we want them to learn, not what nifty toy do we have, what can we do with it? So in 2 of the labs, we felt Skynet was not the best approach. Without going through it in tremendous detail, you'll see some examples, but their 2 main themes are place in space, which is typical of introductory astronomy. They'll use Venusian phases and sizes to show that we live in a heliocentric universe instead of geocentric. They'll do the great debate of 1920, Curtis Shapley, learning our place in the galaxy and the galaxy's place amongst the spiral nebulae. And we also have a Hubble's Law lab that doesn't use Skynet, uses rubber bands, but in a very creative way. I'm very excited about it. But the theme of most of these labs is they collect their own data, or the class does as a group, and they do these things. The other main theme is the cosmic distance ladder. It's the backbone of learning our place in space. They figure out the size of the Earth. They do parallax. We actually observe an asteroid from Skynet telescopes in opposite hemispheres, the main belt asteroid, simultaneously, get the distance. In using some archival data, we do stellar parallax. It takes 6 months, so it has to be archival to get out to nearby stars. Under standard candles, the class observes an R Lyrae. We're going to attempt to do that today and measure the distance to a globular cluster, which enables the Great Debate Lab. We also do Cepheids and Type 1As to get farther and farther out. Along the way, we also do Kepler's third, because you gotta, and the rotation curve of the Milky Way using our radio telescope and some radio H1 spectra. And that's their introduction to radio, their introduction to spectroscopy. And we're adding a lab on multi-messenger astronomy. Back in 2017, you all heard of the neutron star binary merger that had an optical counterpart. Skynet was one of the 6 groups, the second of the 6 groups that simultaneously or near simultaneously discovered that optical counterpart. And so they'll be using that data and maybe collecting their own spectrum of the galaxy, because we have some spectrographs being integrated in. And they're going to work with gravitational strain data, wave strain data as well. That's OPIS. And when we introduced it in 2008, we realized we had struck something. We hit a vein, a good vein. People started posting their stuff on social media saying things like the most exciting homework anyone will ever do. Pretty damn awesome. How often do you assign homework and that is the result? And what it is, we think, are 2 things. And a lot of this ties into the CURE pathway model, if you're familiar with course-based undergraduate research experiences, which is a big thing in education right now. We're not doing cutting-edge research in the class, but we overlap with a lot of the goals of CURE. It's part of the educational research study. But one aspect is they're using real telescopes at real observatories that are also used by real astronomers to do real science. So real, the reality of it makes it important and exciting. Also is image ownership. They're not using archival data except where we have to. And we revamped the lab, so they're acquiring as much of the data as possible, something in every lab, every Skynet lab. So there's an image ownership aspect of this. This is my picture, my image, I did this. And this stuff builds on self-efficacy and attitudes, which the education research community is now beginning to find is just as important as learning gains. And we saw our majors went up 100%, our enrollment went up 100% in 5 years, and our majors went up 300% over that period. We're now in 24 institutions, 3,000 students, and that's double what it was last year because of the NSF grant. And we have the technological capability to grow another factor of 10 if you're interested. And I just put this here because I had no other place to put it. One of the big things we did last year is we film like 60, I film 65 videos, so typically 5-minute videos. They're now embedded in the labs, and the students find them super, super useful for carrying out the labs. And you may want to check them out. They're at that tiny URL. And I'm going to provide a link to a page with tons of links. All this stuff will be on that page. I'll provide that at the end. And a little bit about MWU, and then we'll do what we can in the time that we have. MWU, or Astrophotography of the Multi-Wavelength Universe, 3 million from DoD, 9,000 for participating instructors. The difference is you're going to develop this curriculum. It's already underway. The first 2 of 8 units are being developed by about 24 educators right now. I'm doing the technology piece. Technology has to be developed for this curriculum, adding radio telescopes, radio analysis techniques, all sorts of things. So I'm not doing the curriculum like I did on OPIS. You all are, for those of you who choose to participate. And some of it's for surveying the students as well. It's intended only for students who've done OPIS, or for classes where most of the students have done OPIS. So it's a smaller group of students, which means we can give them more time. The OPIS students get 30 minutes, and it's enough to do the carefully selected activities, right? If OPIS is going to scale to a national level, you can't just observe whatever you want. We have to be very judicious about it. But MWU, each student may have 1 or 2 hours of time, and we can do things like stacking for depth, stacking for color, radio maps, which take a lot of time to, because radio telescopes are 1-pixel cameras. So you map, you go over the sky and fill in the gaps. So they'll be able to do these things. And so these are, the focus is color. 3 optical, 3 radio, and 2 capstone that combine both. You can learn a lot from color. And we're focusing on star-forming regions and galaxies. That's typical of second courses. And light emission processes, including scattering, extinction, and stuff like that. Here's just a few brief examples, and then we'll do the stuff we're going to do. This is Centaurus A, an elliptical eating a spiral. So a great capstone subject. There's a lot going on. They learn about spirals and star-forming regions, how to observe them in color, how to observe them in H-alpha, narrow emission lines, so they can learn about star formation triggered from the absorbed gas, but they learn about ellipticals. So all that's together in the optical. But in the radio, the jets are producing synchrotron emission. And so you can study that. Here's some the other capstone will be the Orion Complex, star-forming region. And this is just a simple preview of what you can do. That's 1-band optical, 1-band radio with false color. But we're working on, we've developed these really sophisticated radio mapping algorithms, as you can see here. It looks great, the one above anyway. And we're working on it such that it's not just false color, but true color. Thermal things will appear blue. Synchrotron things will appear red. Bremsstrahlung, probably a shade of white. So you can really get into emission mechanisms in the radio. So there's all sorts of stuff you can do. You can pull out hydrogen recombination lines around the H2 regions, H1, outside of it, so radio spectroscopy. And here's just another example. This is much, much older software, much smaller radio telescope. That's Andromeda, looking at the H1 line, imaged 3 times at 3 different wavelengths. You can see it rotated from one end to the other. And you can imagine there's great science that can be built out of those kinds of activities. So I'll pause. And well, 2 things. Get these 3, so you don't have to type them. I'll put them in the chat. And as I'm doing that, feel free to ask questions. But load these 3 sites up in your browser. I don't have Control-Z, so I just lost that. But I know that I don't have S either. Oh, it's the same as this right here. 1 second. Copy, I'll put that back. Paste, I paste over here. So that's the first thing I put in. That's the link to Skynet, where you put in your observations. This next thing.
We're not seeing the links come up in the chat.
Oh, I'm not sending it to everyone. Let me try again. Okay. This first link is to the observing page. The second link is to the image analysis page. And this third link trying to navigate without a control button, is to a custom graphing application that we built for OPIS and we're adding to for MWU. And while I'm doing it, I'll just give you this final link here. This will send you to a page with links for all sorts of extra information. Copy, paste. So let me ask you, did you all, and so I can get rid of the PowerPoint. We see I have a lot of people in here. Have you all gotten your Skynet account set up? So give me the thumbs up. And some visual ones and some digital ones, and that's all fine. As you know, if you're having a problem getting your, is anyone having a problem getting their Skynet account set up? I should put it that way. Shout out if you are. But otherwise, many of you may just be watching right now and doing the stuff later. Okay. And have you loaded the 3 pages? We got the Skynet page, the Afterglow page, and the custom plotting page. Okay. So let's go to Skynet first. And again, this will be replaced in the summer with Skynet 2. This is Skynet 1. Skynet 2, I'm really excited about all sorts of new capabilities, but I'm going to show you Skynet 1 today. There are all sorts of things here like links to the various observatories, and you can click on individual telescopes and see what they've imaged recently. Looks like some people have been looking at Sombrero, etc. It tells you what filters are available. There's Skynet Live, it shows you what's going on right now. These are the scopes that are currently connected. Currently, our one in Australia is cranking away for David Sand. That's his supernova survey. And other ones, you know, the weather's good or bad, but the sun is up. And then My Observatory, that's the prime place to go. You'll see optical observing, radio observatory, and ways to modify your account. And once you're, you know, if you do use the curriculum with your students, you'll be made a group manager. Your students will be in the group and you'll have group management capabilities as well. Go to optical observing. So this one right here. And you'll, if you're a new user, you won't see anything, but this is where your observations go once you create them. You can see I have pages and pages of them. To create a new one, go over to Add New Observation right here. I pause just to make sure everyone's still with me. I'm going to click on it. If anyone gets stuck or lost or I went too fast, just shout out and we'll do something about it. And we are going to add an optical observation. So you can do it various ways. You can click on, let's see, that's the Now button. So going a few hours into the future, you can click on objects. If you know, you can use this to explore the sky. You can zoom in. Or you can use a keyword like I'll do Saturn. Okay, I don't have an S key. I'll do Jupiter. Yes, I have all those keys. So Jupiter it is. And I'll zoom out and let's see, where is Jupiter? Let me back it up a few hours. There's Jupiter, okay? And it puts the name in here. You can rename it anything you want. Puts in the coordinates, so it will update the coordinates moving objects right before it dispatches. And it's currently set, for me anyway, it's waiting for the sun to be 12 degrees below the horizon and the target to be 30 degrees above the horizon. Students usually use -12 and 20. Professionals use -18 and 30. Up to you. We have advanced settings for dithering and offsets and orbital elements of strange objects. We can close that out and skip it. And you look at your observation chart and just make sure that your target is above the gray line. That's the 30 degrees I put in. I can change it to, I can't change it to 20 because I don't have a 2 button, but 19. And if I click off that, the line goes down. And so you can, as long as you have something above the line over the next 24 hours, you can observe it. Everyone with me so far? Okay. Next, we're going to pick our filters. And that's this button right here, lower right. Okay, and our telescopes have all sorts of filters. Let me turn these off for a second. These are the telescopes that can view your target given its latitude over the next day. Now, Jupiter is really bright, so I often look in U-band and see that blocked out a lot of telescopes. A lot of telescopes don't have U-band. That's okay, some do. And you can do multiple filters. Let's do U and B as an example. So there are a handful of telescopes that have both U and B filters. You select those, save and continue, and it will take you to the telescope selection page. Now, for you, the accordions might have been closed, and so they're under Johnson Cousins. You open up Johnson Cousins, select U and B in this example, save and continue. And then you have all telescopes that you have access to that can hit that latitude, that have those filters. And if you press the little orange button, it'll just select all of them. And if you just want to restrict it to the highest quality telescopes, you can select prompt. But I'm just going to leave them all in right now to show how it works. Now there's prompt use Saskatoon. Okay, save and continue. So here are all my telescopes.
Could you go back for a second? How did you, I only have one screen, I'm at home, so I'm trying to juggle. How did you select the telescopes again?
So you can press the orange button to select.
Orange, okay, gotcha, I missed it. Thank you.
Or you can pick individual scopes. But the more scopes you pick, the more likely it is to go through. If you pick one telescope and it goes down or is weathered out, the student's waiting a long time. This is the advantage of a global network. It's going to be clear and functioning somewhere, and you should get your data back within a day. Okay, save and continue. And then we're going to pick a duration. And I had practiced this before, so for you, it comes up blank. So in U-band, let's do one exposure, 0.3 seconds is a good duration. And in that sign-up sheet, I have tables with good durations and good filters for various objects, just to get you started. Now you have to pick a design telescope. Every telescope's different. So I tell my students to pick the generic 16-inch. It's the same as prompt 5. And you can see if I slide over every telescope, it has a different duration, depending on the quality of the telescope. Lower quality telescopes will observe longer to achieve the same signal to noise. B band, let's do one exposure. That lets a lot more light through, so maybe 0.05 seconds. Again, different exposure lengths depending on which telescope takes it, but it costs them the same number of credits. Even though it's a longer time, it's a lower quality telescope, those two numbers multiply and they get charged the same number of credits. There are fancy features like repeat this observation 20 times with 1 day between each. If you want to do that kind of thing, but we can just ignore that for now. That we have a lab where they look at the gas giants, the gas giant of their choice, they repeat it once a day, they track a moon going around it and figure out its orbit and hence the mass of the planet. Anyway, save and continue. And it's just a checkout screen. You submit it and it will be in your list. There it is at the top of my list. I'm going to pause. And once everyone gets there, you can give me the thumbs up, and then I'll show you how to look at your images. Then we'll have to pick and choose. This goes until 2:40, and so we have 16 minutes, and we'll pick and choose an activity or two to do. Okay. So let's go there. We're going to go to Afterglow next. It's this one it's the afterglow.skynet.unc.edu. When you logged in using your Skynet credentials. And let's go to the open files. That's this over here. There's some crude viewing options on the Skynet page, but this is for like fancy image manipulation. So let's open up the file directory and you'll see sample, Skynet, and workspace. Skynet, when your images come back, they'll be in there. Workspace, you can upload your own images or save images as you're working on it. But let's go into the sample directory and into the workshop directory. I have a few things for you today. And so the first thing to load, let's load the Jupiter. I'm going to cut a few things out. Let's go to Jupiter Color. So in there, I have 3 images that I took about a month ago in 3 different bands, Jupiter's so bright that you can't do red, green, blue. Even in our minimum exposure time, it saturates. So I used H alpha for red, O3 for green, and U band for blue. They don't let as much light through. So you can select on them individually or select them all, and then press the open button. I've already done that, so I'll just cancel out, and here they are for me. And if you click on it once, it brings it up. You click on something else, it brings that up, and the other one brings that up. If you go back to the first one and double click on it, it pins it. So then if you click another, it brings it up as a new tab. So I'm not gonna bring them up yet. Let me close them out. What I'm gonna do is I'm gonna select all three. Well, let's bring up one. So we have H alpha there, and this is Jupiter. And you have some manipulation settings. Over here, we have ways to manipulate images and measure things. The first one on top is display settings. So at the top, we have some coarse brightness and contrast presets. I'll click the bright target, and actually red's a bad one. Let me bring in like U band. You can really see the details there. So lots of nice details on Jupiter in the bluer bands. But if you're looking for the moons, default is good. And you also have fine adjustment. See, I'm decreasing the sky glow around Jupiter. Sometimes you can bring extra moons out of the sky glow around a planet. And students do a lab where they measure the distance between the planet and the moons. We did this last year during the ASP workshop. There's a tool down here for measuring distances between objects. And it gives you the distance, and then you can figure out the orbit using some other tools I'll show you.
I'm sorry, where was that tool?
That's 4 units down.
Oh, I see, okay.
But we're not going to do that this time because we did that before. Let's do an MWU activity, which is color. I'm going to show you how to turn these into a color image. So if you have all three selected, go up to the triple dots and select group. And it will group them together into a multi-layer HDU, multi-HDU, so a multi-layer FITS file. And so there's an overall one. It may take a second to load. Mine are loading fast as I loaded them beforehand. Once you click on them, they're coming from the server, so it sometimes takes a few seconds to load. The one on top, I'll double click on it to pin it, is the combination of the three. But let's load the others up. You can split the screen if you want. I loaded one, and I'm gonna split this one, right click on it, and my mouse is kind of crappy. Split down, and maybe I'll bring load another one in, and I'll split that one right. And I'll come back up here and load in the other and split that one right. And you can also move these. I'll just put another image in one of these here, and you can move these from tab to tab. You can bounce them around and do things like that. Get rid of them by hitting the X button. Let's see, I lost one somehow. I think it was this one.
Hang on, I lost how you split the screen. I heard right click, but that's not working on the Mac.
On the tab, it should be a right click.
Oh, on the tab.
On the tab, yep. And so center them up. And we're gonna go back to image display at the beginning. And in the red, green, and blue images, like here's the U band, I put that on bright target. Here's the green band, O3, put that on bright target. And H alpha, put that on, it's already on bright target. And so now I'm gonna colorize these. The U band one, I clicked on that, and down under color map, I'm gonna use the blue color map. And for O3, I'm gonna use the green color map. And for H alpha, I'm gonna use the red color map. And this one has automatically combined them. And you can tweak it. You can go into any individual one. Maybe you don't like linear, maybe you like hyperbolic arc sine, or you can do different things. You can adjust the saturation level, the background level, and create the image you like. In fact, I'm just gonna ditch the individual frames by hitting their X's and zoom in on Jupiter here in color. And maybe I'll rotate it around because I'm used to seeing the great red spot down below. But that's not bad. That was 0.4 seconds in U and 0.2 seconds in the other filters. And so you have a color image. And you could do this with deep sky images. We have alignment capabilities for WCS images. And so some cool things can be done. Questions about that? Okay, let's try. We have 10 minutes left. I'm trying to decide what to do. We have, well, I think what I'll do is I'll show you the next one, and I'll do it kind of quick, so don't try to follow along, and that'll leave time for the final one, okay? And so the next one.
I actually have a generic question, if you don't mind.
Yes, go for it, please.
These are all labs, clearly. What kind of like background so I'm assuming the students are also going to be learning, having like background for like what exactly they're doing. It's not just like, you know, click this, follow along. Like it's not black box kind of situation.
The labs have background sections. They're focused, giving them just what they need to do the lab. And they're as minimal as possible. The idea is they're like, this is MWU, the color combination. So this would be a second semester course. They're learning about stars and galaxies and all sorts of things tied to color. But the OPIS ones are black and white. And the labs do have background sections. I have links to PDFs of the lab in that extra document. But they're designed to accompany standard introductory astronomy curricula, which is usually a tour of the universe, maybe solar system one semester, stars, galaxies another semester, or the whole universe in one semester. These labs are the greatest hits of the past. The OPIS labs are the greatest hits of the past 400 years. The MWU labs are going to be in-depth color explorations of regions of space, star-forming regions, galaxies.
Just as a follow-up, are these meant to like, because I'm curious, are these meant to like be as in a course where they have like its own lab section, or could be part of like an overall like lecture style course that has labs that have to be incorporated into the lecture time?
People do it both ways. Some people, like at UNC, we have it as a separate lab. Some people incorporate them into the lectures. You don't have to do all of them either. You can pick and choose.
You read my mind for the next question. Thank you.
Yeah. We accommodate all types, and our surveys are built for studying it in that fashion. Okay, we have 7 minutes.
I have a question as well, which is kind of a follow-up, because apparently I read her mind. I know this is designed for survey courses, and I can see some use in that. I also have an astrophysics course that I'm teaching. We don't have an astronomy major at all, but some of my physics majors are taking a 300-level astrophysics course. Are there activities that could be applied at that level, like I'm making them do the math, but also use the telescopes along with it?
Yes, so MWU might be a better fit for that. It depends. All schools are different, and you'll have to, as the MWU curriculum's developed, the people are developing or trying to do it in 2 ways, like quickly integrate it into the class and more in depth, maybe using some Python to do some of the skills. Okay, so given the last time, I want to show you something in radio. So let me go to the interface, and I'll just kind of overview some of these other activities that they do. So you have an idea. And so this is Afterglow. You can measure things. We have a photometry. What I was going to do, I have all these images. Now I'll show you just a little bit here. So here's a globular cluster. And I'll do this. We won't try to follow along to do this to save time. Let me rotate it in a way that I'm familiar with it. I know this is an Lyrae star. Let me go down to the photometry tab. And so this is an Lyrae star. This is the reference star that we use. We click on them, give it a second. The server's being hit. It came up with magnitudes and showed you the aperture and annulus. We have a batch photometry mode. And so you can do all these images together. It's already found them in the other images. And actually, if I switch to adaptive photometry, they'll redo it, and you'll see it deals with wind streaked images nicely as well. And so you can batch photometer all this stuff out. And this is our custom graphing tool that we use with the students. And you can plot it up in here. I'll just hop down to that. Oops, that's a different one. Hop down to this one. I'll open up a batch photometry file that I did recently. And so this was the reference star, and the magnitude of, this was the variable star. The magnitude of the reference star was 13. So this is in our Lowry 6 days of data. We have a periodogram built in. So its period is about 0.333 days. And there you see, there's our Lyrae varying, and you can get its middle magnitude. And knowing that all our Lyraes have an absolute magnitude of 0.75, you can get the distance to the globular cluster. And they do other labs where they do a bunch of them, and they enter the longitudes and latitudes and distances they computed, and they get a top-down map of the Milky Way, the globular cluster distribution, learn that we're not at the center, learn the size of it. The last activity I want to do is one for multi-wavelength universe. I don't have time to show you how to put the observation in, though the information is down here near the bottom of how to do a radio observation in Skynet. And this is how to do it. In the videos, you can find it as well. Just 1 minute on a bright pulsar. And let me go back to the graphing tool. We recently built this for MWU. I'm going to load in pulsar data. In fact, you can do this as well. I have it in the sheet, this link right here. If you go to that link, this is pulsar data that Skynet returns, and you can save it as some file. I'm going to save it as some file. I'm going to copy this since a lot of my keys don't work. You save it on your computer, and then you go to the graphing interface and you upload that file. Paste. And it loads it in. And this is a bright pulsar. You can see the individual pulses, but this activity works even if the pulsar is lost in the noise. And so again, the periodogram, I'll compute it. And you can see there's a spike here around 0.7. In fact, you can actually look at it in frequency mode as well, compute that. And you get the primary frequency, and then all the overtones all the way out to Nyquist. But if you go back to the period mode and zoom in, it was between 0.7 and 0.73. So I'm gonna zoom into that region, the periodogram. So 0.714-ish is the period of this pulsar. And zoomed in, and there you see the pulse profile. And if you look carefully, one is leading the other. As the pulsar is sweeping by, you have field lines curved this way and then field lines curved that way. So you have different polarizations, and both polarizations are plotted. And you can plot the difference. And we send students through an exercise to figure out the calibration, but you can't make it go away. One pulse is leading the other, and you're basically seeing the polarization change as the pulse goes across. And that goes into lessons about non-thermal radiation. Anyway, I'm on my last minute, so I'll stop and I will just remind you of the links. You can get all sorts of extra information here at tinyurl.com Skynet-links, and including my contact information if you're interested in participating in either of these groups. I'll pause for any last rapid questions.
We had a pretty good, kind of conversation in the chat having to do with the applicability to this, to some, other courses that they're teaching. So they see that there's a lot of flexibility with this.
A lot of flexibility. Everyone's using it differently, and it's a fun community. We meet once a week and chat with other astronomers who all have good attitudes, and it's actually enjoyable. For some of the astronomers who are by themselves at their institutions, they really look forward to it. And
I'm excited about trying this with a new upper level class I'm developing. So thank you for the information. This looks fantastic.
And there are links on how to do course proposals for like MWU, and I can give you the one for OPIS as well. in there, just feel free to reach out to me. I'm happy to work with any of you. We're adding lots of new instructors now.
I already sent you an email. This is just so in line with what I just proposed to my college, and this is exactly what I was looking for. And for those folks in the chat who are saying like light pollution, I'm in Seattle. We have clouds and light pollution. You can't anyway, and this is the direction that real astronomy goes anyway. It's remote.
It's clear somewhere on the Earth, and if you put the observation in right, I mean, often observations come back poor, fuzzy, satellite, but it's real life observing as long as the students put the observations in early and check. And these labs involve a little bit of math. They may be a little bit more different than they're used to, but I think that counteracts the coolness of it. The coolness of it counteracts the bad stuff.
Yeah, that ownership piece.
The ownership is huge.
Mm-hmm. Anytime a student feels like this is theirs, I feel like they're able to overcome more hesitancy that they may have already had.
And the videos are really helping the students, and so you may want to check those out as well.
Quick question about just usability. Does this stuff work okay on like tablets and iPads and stuff, or is it better with like a computer or a laptop?
Better with a computer or laptop has been our experience. Some people have done it with tablets and iPads and have gotten through for the most part. Some of the labs make use of Stellarium, and I'm not sure of its performance on the smaller machines as well. Yeah.
Not great.
Yeah, and so you're better off with laptops.
Well, fantastic.
It's all web-based though, so they don't have to like download anything.
All web-based, and I have a team of programmers always making it better, and we're really receptive to user feedback. And so every few weeks we roll out updates and bugs get squashed, and we're building this as it's being used. And so there's a chance to shape where it's going.
We have a lot of students who are on school provided Chromebooks through their high school. And Chromebooks are this no man's land between being a tablet and being a laptop, and sort of work worse than either. But this is web-based, so it feels to me like it might work on a Chromebook better than on a tablet.
I noticed one bug with the Chromebook over the past week. My programmer already fixed it. I think it works with Chromebooks.
That's cool.
All right, well, this is really, really great. We've got a great conversation. I'd invite everyone to pop over into the midday networking break and maybe join, Dan, maybe if you go there and if you go into a room, there's going to be some breakout rooms where you can have some more in-depth conversations. And so I invite people to go over there. And then our next plenary is not quite an hour. We're 3 minutes shy of an hour. So 57 minutes from now is when our next plenary will take place. And so I want to thank Dan for being here, and thank all of you for being here and making this a good conversation.
Thanks, everyone. I'll try to find the
Thank
midday
you so much.
booking.
Okay, well, take care. We'll see you at the next session.
See y'all.